So we're going to go over this activity together, and the first problem asks for the leading term. So we pull out the highest order of every single term. Don't forget to include their orders. So what I end up with is something that looks like this. So if I were to group them together, negative 3 times negative x cubed times 2x times 3x cubed is equivalent to negative 3 times negative x cubed times 2x times 27x to the third. The coefficients were negative, hence positive. 2, 3, hence 6 times 27. 6 times 27 is 162. The order is 7, so my leading term is this, where the degree is 7 and the leading coefficient is 162. So we want to sketch the graph. Of course, it would also include the idea of intercepts. So you want to find the zeros and corresponding multiplicity. In order to figure that out, first you set every single piece you have here to be 0 and see what that lead to. The first one needs x to be 2, the second one needs x to be 0, third one needs x to be negative 1/3. The order were 3, 1, 3 correspondingly. Therefore, you try to sketch the graph. You would have intercepts as 2, at 0, at negative 1/3. And because clearly when it's intercept at 0, it's both x and y intercepts, so I don't really have to worry about the y intercepts anymore. We try to look at the end behavior. Positive x to an odd number looks like the function x, so it's right and left up, so this is my end behavior. What's left in the middle is you need to go across the x-axis because they were all odd powers, so that's why you end up with something like that. And the next problem I have, well, don't forget you want to factor to the simplest version, so it's 2x and x minus 1. And then you have x minus 6 and x plus 1. The reason I want to simplify it to the simplest version is because I want to find x-intercepts later, so I want to find all the terms that making my function to be 0. But if you were only to look for the highest order term, you could have started from here, and it would give you the final answer directly, which is 2x to the 4th, so the degree is 4, and the leading coefficient is 2. Positive x to the even order, your function should look like this. And the zeros of your polynomial is look at all the factors and find out multiplicity and find out when would your function be exactly 0, which means it's 0, it's 1, it's 6, it's negative 1. They are all of order 1. So what you're going to end up with is your function is going to intercept as 6, 1, 0, negative 1. And your two ends looks like that. And what happens in the middle, again, they were all odd, so it's always go across, so that's how your graph is going to look like. The next problem, I'm sorry, I made a mistake, so I should have filled it in. So you can feel free to ignore this problem. I didn't have the function written down, so never mind. Well, the next problem, I want you to construct a function such that the graph looks like the one given below, where this is a 5 here, where I have a 0 here, where my end behavior is up and down. Okay, so in order to achieve that graph looks like that, first of all, because of my end behavior, you know my leading term should look like positive x to an odd power. And then because of the zeros, I realize I should have 0 and 5. And the multiplicity I end up with, clearly the 0 is odd multiplicity, the 5 is even multiplicity, and that's literally every information I have. Therefore, all I need to do is propose some function that makes this structure make sense. For example, I could have positive 2, right? And x minus 0 to an odd power, and x minus 5 to an even power. I could have f of x to be a positive coefficient in the front, x minus 0 to an odd power, x minus 5 to an even power. They're all going to work out. So the solution is not unique. And in order to have the solution to be unique, we need some extra information, which is not exactly what we are asking here. I may be asking something that's provide you with a unique solution, so you want to make sure you take advantage of all the information given to you. The next problem said I have a function that's given to you. I want you to find the particular case of k such that my function goes through the point 2, 0, which is another way of saying f of 2 equals 0. So f of 2 equals 0. It means f of 2 is supposed to be k, 2 to the 5th minus 2 squared plus 5 times 2 plus 8, which is supposed to be 0. So it's minus 4 plus 10 plus 8 equals 0. 2 to the power of 5 is 32, so I have 32k. So I have 32k is the same as adding to 14. Therefore, 32k is negative 14. In other words, k is negative 14 over 32. Again, simplification is not required, so you could have left like that, or you can simplify it slightly further. The remainder theorem can be used to find f of c. It's essentially equivalent to whatever remainder you can find, as it's the same as the remainder of f of x divided by x minus c. Therefore, what you're looking for is you want to look for a synthetic division, whether you have 15, you have 17, you have negative 30. Well, there's a term that in the middle that's skipped. So that's why you want to say this is technically equivalent to plus 0 times x before you move on to the next term. Therefore, I have 17, I have 0, I have negative 30. I want to divide by x minus 1 over 5. So it's 15 here, it's 3, it's 20, it's 4, it's 4, it's 4 over 5, which is 0.8. Hence, I have negative 28.2. In other words, f of 1/5 is negative 29.5, which is according to the remainder theorem. The next problem I'm asking you for the quotient and the remainder. We keep using r as to represent the remainder. So what we are going to do this division, you want to make sure you fill in all the missing terms. So there's x to the 5th, there's x to the 4th, there's x missing. So your leading coefficients were 2, 0, 0, 3, negative 4, 0, and 1. You are going to divide it by x plus 1. X plus 1 is x minus negative 1. So you're putting negative 1 here. You need to make sure it's minus something. So you end up with 2 here, which is negative 2. And then you have 2 here. And then you have negative 2. You end up with 1, which is negative 1 here. And 5 here. Negative 5, negative 4. Okay, let's just double check. So we have 2. We have 2. We have negative 2, we have negative 1, we have 5. Okay, so what you end up with is the remainder is negative 4, and your quotient is to count backwards. So it's order of 0, 1, 2, 3, 4, 5. So the highest order term is the 5th order. So it's 2x to the 5 minus 2x to the 4th plus 2x third plus x squared minus 5x plus 5. So this is supposed to be your answer. Well, the next question says, can I use synthetic division to find out what's the quotient and what's the remainder when I have f of x divided by x squared plus 1, which, by the way, we have emphasized it's a quadratic function. And we said remainder theorem and synthetic division, both of which handles division when the denominator is x minus c. So it can only work if it's a linear denominator, so that's why it's forced. This one is not okay. We want to use synthetic division and the remainder theorem to find out f of negative 2 given f of x is that, which is, again, you want to fill in all your missing terms. So x to the 4th, x to the 3rd, x squared, no x term, and you have x minus negative 2, so that's your c, which means you have 3, 0, 0, 1, 0, negative 16, and you have negative 2 here, so you end up with 3, you have negative 6, which is negative 6, which is 12, add up together, you end up with this, and it's 46, you have negative 92, hence negative 108, which, again, last term is a remainder. Your quotient, you want to count back. It's order 0, 1, 2, 3, 4. So what you're going to end up with is your quotient is supposed to be 3x to the 4th minus 6x cubed plus 12x squared minus 23x plus 46. And your remainder is the last term left out there, which is negative 108, which forms your final answer. So the last problem, we have different ways of looking at it. It says it's divisible, which basically means its a remainder is 0. So we say 16 is divisible by 2. Okay, something like that. 13 is divisible by 1, and 12 is divisible by 2, by 6, by 3, and by 4. Basically, it says remainder is 0. So if you want to find the remainder of 0, there are two ways to look at it. One way is, say, if your remainder were 0, the f of c is supposed to be 0. C comes from x minus negative 2, which was x plus 2. So it's basically say you are telling me f of negative 2 is 0. So this is idea number 1. You can work it out. So f of negative 2 is negative 2 cubed plus k times negative 2 squared minus 2k times negative 2 plus 4, which is supposed to be 0. So it's negative 8 plus 4k minus, okay, actually plus 4k plus 4 is 0. So 8k minus 4 is 0. So k is 1/2. Another way of looking at it is divisible, which means remainder is 0. Remainder is 0, which means when you carry out your synthetic division, you should end up with a 0. So you are going to carry out your synthetic division. It's 1 here, it's negative 2, so it's k minus 2. K minus 2 times negative 2 is negative 2k plus 4. You add them together, it's negative 4k plus 4, and you times 2, which is 8k minus 8. So you add up the 4 on the top, it's 8k minus 4, and like we said, remainder is supposed to be 0, so you get 8k minus 4 is 0. Again, k is 1/2. So both idea gives you the exact same solution, either one works. Bottom line is you see this is divisible, which is related to remainder. So the only two things we know about remainder is the synthetic division and the remainder theorem. So either one works.